Hello guys, I hope you're doing alright, and here we are in a new video about logics. Okay, now last week we were talking about propositions, the denial of propositions, and what was the difference between the propositions and the statements, alright? So check the last videos and remember these concepts, which are very important to go on, okay? So now we will continue with this topic called logical connectives, okay? And we're going to start with the first one, which is called conjunction. What is the conjunction? The conjunction in the language is when we use the word and, okay? So for example, P and Q. We have two propositions, P and Q, connected by the word and, by this connective, okay? When you have an and connecting the two simple statements, it means that both statements must be happening at the same time, all right? For example, if our first proposition is the room is blue and our second proposition is the lamp is blue, then P and Q means that both the room and the lamp are blue, all right? Both statements will be true or will be false, all right? The conjunction of P and Q is the statement P and Q. We use this symbol to represent the word and, all right? This represents the word and. For example, if we have other word sentence like I like pizza and I also like hamburgers, all right? So I like both pizza and hamburgers, all right? So the connective used here will be the word and, all right? So this is the symbol that we use for that, which we read P and Q. Its truth value is defined by the following truth table, all right? So we are going to build these truth tables, all right? We always have the first proposition, P, we have true, true, false, and false, always the same. For the second proposition, true, false, true, and false. Okay, this is a rule that we will always have when we have the connective and, all right? So when we have true and true, the result P and Q will be true. In the other cases, for example, true and false, the result will be false, always. When we have the proposition P is false and the Q is true, false and true will be false, all right? And the last one, when we have false and false, then we have P and Q will be false. Okay, can you see that here the only example where we have as a result a true statement will be when both of them are true, okay? What happens when one of them is true and other false? It doesn't matter if it's P or Q. So always will be false, all right? Okay, we're going to use this table. You don't have to memorize it yet. We're going to use this in the examples, okay? Because it will always be a specific rule that we are going to use to solve the examples, okay? So let's continue. Now we will see word problem, all right? So for example, here we have other example of conjunction. If P is sky is blue, this is the first proposition, and Q is 1/3 is less than 1/2, a half. Okay, so we are going to find what is P and Q. What are they asking? Is it true or false? All right, is it true or false? Okay, we're going to find out what of this truth value we'll have here. Okay, so let's start with the first proposition. In this case, we're going to analyze the first one, and we build a table, a mini table here with P and Q, because they are asking P and Q, all right? So let's find out the first one. In the first one, 1/3 is less than 1/2, okay? If we solve this division will be 0.33, all right? This is like 0.33 less than 0.5, all right? And we realize that this proposition is true because this is less than this. Okay, so the first truth value of this, oh, I'm sorry, I was here. P, sky is blue. This is true. Okay, so we can say that it's true. All right, and we already have the truth value of Q, and we realize that this is true also. Okay, so this is true. So we write these truth values here. So we have P is true and Q is also true. That's right. So now we find out if P and Q, what is the truth value here, if it's false or true. So let's check in the table, our useful table here, and we check that T, true, and true will be true. So the final answer is true. Okay, so P and Q is true. This is our final answer. Okay, so always remember the step. We find the truth values of the propositions, then we use the table to realize if the final answer will be true or false. Okay, okay, so let's go on to the next slide, and here we have other example. So now we are going to find if P and, do you remember what is this sign? This is negation. Okay, P and negation of Q, of denial of Q, what will be that? So let's find out. Here we have the first proposition, P. Ottawa is the capital city of Canada. Okay, so let's find out. If I guess that you already know that it's true, all right? Because Ottawa is the capital city of Canada, not Montreal, all right? Remember that. So this proposition, P, is true, right? Let's do it with other color. For example, with red, much better. So let's write it here. That would be true. Okay. And then the next proposition would be 2 plus 2 equals 4. Is that true? Of course. So Q, in this case, this one, this truth value is, of course, true. Okay? True. All right. So this is the most important part. If Q, the proposition Q is true, the denial of Q, so the negation of true, will be the opposite. So the negation of true will be false, all right? This is exactly the opposite, okay? We already have the negation of Q, that is false. Now, how can we find P and negation of Q? How can we find that? So we have to look at the table. So we already have P, in this case, is true, all right? And the denial of Q will be false. We have to find if true, all right? If true and the denial of Q, that is false, what result do we get here? So we look at the table, true and false. We can see here that true and false will be false, okay? So the final proposition will be false, all right? So this is our final answer, okay? False. And here we have this example. Now, let's go on with the next one. Here we have a word problem, and it says, the proposition P says, there is life on Mars, and the proposition Q is, there is no life on Europa, all right? So let's see if that's true or false. How can we find, not if it's true or false, how can we write this with words, P and Q? So the right answer of this is, there is life on neither Mars nor Europa, all right? So that's the final answer, okay? Because both of them, to mention both of them, both of them are negative, so we use neither, okay? This is the answer, all right? Okay, now let's continue with some mathematical expressions which are really, really important. We're going to do it little by little, okay? So here we have the following proposition. The first one, we have the proposition P, and it says 2 plus 3 plus 5 minus 8 is less than 12, okay? And the other one says 1 over 3 plus 1 over 4 is greater than 5 over 3. How can we find out if, how can we find the denial of P and Q? So first of all, we have to find the true value of P and the true value of Q. And how can we find it? So we have to solve this operation, okay? So let's do it. So it will be 2 plus 3, that makes 5, 5 plus 5, that makes 10, and 10 minus 8, that would be 2, all right? So here we found that 2 is less than 12, all right? So now the question is that true or false? This is true, of course. So the truth value of this, P, will be, this is true, okay? This is true, of course. Now, in the second one, here we have a fractions, two fractions. We have to add them. Once again, remember how can we add unlike fractions, because we have different denominator. We have to find out if this addition is greater than 5 over 3. So let's find out. We have to solve this addition, and remember, when we have unlike fractions, we have to get the same denominator. So how can we get it? We have to multiply by a number to get the least common denominator, which is 12, okay? So here we multiply 3 times 4, all right? 4 over 4, okay? To get 4 times 3, that makes 12, and 4 multiplied by 3 to get the same, to get 12. So this multiplied by 3 over 3. So we do the operation, so 4 times 1, 4 times 3, and that will be 4 times 1, that makes 4, over 4 times 3, that makes 12, okay? Okay, we already have this, and 1 times 3, that makes 3, and 4 times 3, that makes 12, okay? So, of course, now we can add these fractions, all right? So let's write the fraction lines here and here. I'm sorry for the line. So now we can add 4 plus 3, that makes 7, 7 over 12. All right? Okay. So this is our final fraction after adding them, and then it says that this is greater than 5 over 3. All right? So how can we find out if this is greater than this? Okay, how can we find out? We have to multiply this to get the same denominator. So we have this multiplied by 4 over 4, okay, to get a 12 in the denominator. Okay, and of course we multiply the numerators and the denominators here, okay, and here we have 7 over 12 is, here we have 20 over 12, okay. Okay, guys, so now here we have the greater than sign, and we're going to find out if this is greater than this, okay? In the next video, I will show you how can we compare this and how can we find the last answer, the denial of P and Q, all right? Okay, guys, see you next video. I will show you how to finish this example. All right, see you later.